Hello, here we're going to find the antiderivatives of some functions right here. Now, what's the antiderivative? It is a function such that when we take the derivative, and I'll call it capital F, when I take the derivative of capital F, then I get little f. So I'm going to try to find capital F such that the derivative of that guy equals little f, and little f is given above. And what I'm going to do is I am going to use the power rule, not of derivatives. I'm going to use the power rule for antiderivatives. You could call that the power rule of integration. And so what that's saying is if f of x is equal to x to the n, then capital F of x is equal to x to the n plus 1 divided by n plus 1. However, this only works if n is not equal to negative 1. If n equals negative 1, you'd get negative 1 plus 1 is 0 in the denominator. And I'll say it without writing it down right now, that if n does equal negative 1, then little f of x would be 1 over x, and that antiderivative is natural log of absolute value of x. Okay, so, and by the way, I'm going to rewrite this just a little bit. I'm going to write down the general antiderivative by adding c. So let me highlight this, and that's a good one to use. So we're going to use that throughout. All right. So for this particular problem, as you see a little f of x up here. Let me just go ahead and work through this. So when I take the antiderivative, I leave the 5 alone. Similar to taking a derivative. You leave constants alone when they're multiplied by a function. And now, let me make it clear what I'm looking at right here. I'm looking at this 5x to the 4th. So I look at x to the 4th and use the power rule where I have, it's x to the 4th, so I take the 4, it's x to the 4th, take the 4 and add 1, which gives 5, and then you divide by that number 5. Of course, there's cancellation there. Now let's move on to this next little piece here. I'll highlight that also. The 4x to the 5th. It's a little harder to see now that I did that, but anyway, I have 4x to the 5th. What I'm going to do is I'm going to take the 5 and add 1, and I get 6. And I divide by 6. So, okay, that was that piece right there. And then I go ahead and add c. And what you can do is you can check to see that this, in fact, is an antiderivative by just taking the derivative of it. Take the derivative of this guy here, see what you get. So there's cancellation. And that's the answer. I guess these are from Openstax, but I'm almost wondering if I happen to have written down the problem wrong or something. Oh well, I think that's it. Okay, let's move on to this one. So now that we got the power rule, we can do this pretty quickly. You have x to the first power. So, all right, so you see, highlight here. That's x to the first power. So you get x squared divided by 2. And then we'll go over to x to the second power, leave the 12 alone. You get x to the third power over 3. So capital F of x equals x squared over 2 plus 3. So these are all from Openstax Calculus Volume 1. I copied them down, so maybe I copied the problem down wrong, but what I'm doing here I think is correct. But I don't know why I'm assuming that all of a sudden, but okay, this f of x is 1 over x to the 1/2. that is x to the negative 1/2. And it's important that we write it that way so I can use the power rule. So I have to write this as a power of x. So then capital F of x is x to what? Well, you take negative 1/2 and add 1, and you get positive 1/2. Well, what did I do? I did that in my head. So let me do it a little more slowly. Negative 1/2 plus 1 divided by negative 1/2 plus 1 plus c. So this is equal to x to the 1/2 divided by 1/2 plus c. So this is equal to 2x to the 1/2 plus c. And I think it's okay to, if you want to, put that back as a radical. Okay, so that's just 3 sort of beginning problems where we find the antiderivatives of some functions where we use the power rule. That's from Openstax, Volume 1. I retyped these, and so on the way when I retyped those problems, I hope I copied them down right. But out of the problems that are written here, these I think are correct. Okay, so that's all.